the actual introduction. So let's jump into this. Celer network is a layer 2 scaling construct. And as you have been hearing about this whole night, that we are inserting one layer in between the decentralized application and also the blockchain. Now, what exactly is Celer network? It consists of two parts. One is the technology part called C-Stack, which is itself a layered technology architecture with C-Channel, which is providing the capability to generalize the state channel and generalize the layer 2 scaling. Not only just like simple payment or simple application. And then on top of the C channel, there's the C rod, which is, you can think of that as the performance engine of the state channel network. So it makes the state channel extremely fast in terms of routing the payment or routing the generalized payment. And then on top of that, we have COS, which is effectively an operating system layer or an API or SDK layer that is finally facing the application the stuff that is building on. Now, besides the technology construct, we also have the first ever layer 2 crypto economic constructs, including liquidity backing auction and the proof of liquidity committed mining and state guardian networks. So, what is the crypto economics? It is basically incentive designed to solve critical challenges in the crypto economics or blockchain system. In layer 2, in layer 1, the crypto economics is basically the consensus layer, right? So how do you achieve consensus among different nodes? But in layer 2, there are also very important crypto economics problems that need to be solved. And specifically in generalized state channel network, there are problems about how to make sure that the off-chain state is always available for on-chain dispute, for on-chain potential dispute, and also how to solve the data connectivity issue where like someone might be offline during the interaction on the state channel, and then thirdly, how to obtain enough liquidity to actually run a state channel as a state operator. So these questions, we actually propose a holistic solution to solve these things. But before we go into that, we actually have launched our testnet, and our mainnet is coming very soon. It's coming like in 2 months. And on top of Ethereum, we already achieved about 20,000 times faster finality latency because, this number is kind of a marketing issue because, the state channel is like instant final versus the probabilistic finality provided by the underlying Ethereum. And we have off-chain smart contract support, fully support, and we also proposed or released the first mobile wallet support off-chain scaling, and all these other things. And we are actually the multi-blockchain support construct. We support both EVM construct and as well as the WebAssembly-based construct. So we're not only focusing on the technology itself. We do focus a lot on the technology innovation itself. We are actually the first one to propose the generalized state channel, specification, but we also focus very much on user adoption, user application. So this is the Celer X that we recently released as a user accessing platform towards the Celer network testnet. And on this platform, what you can do is you can just like do this kind of things. So, so this is like a screen recording. You can actually download the Celer X at celerx.app. This is just some very, very simple demonstration about sending some token instantly to your friends. And as you can see, this is implemented on state channel, so the sending process is extremely fast. Now, the interesting part is this. So you're playing with your friend a Gomoko game, like basically 5 in a row. You connect the 5 stones in a row and you win. And at the same time, you're playing with your friend with like a GT token. What is GT token? It's a ERC20 token we issued on the Robson network. So you can replace that with like any kind of stable token of your choice, right? So now you're basically betting the game with your friend. Now note that this, in the beginning of the game, what happened really is that you send each other a conditional payment off-chain. This entire application, there's no server, it's fully decentralized. It's just in the beginning you send each other a conditional payment. And that conditional payment is conditionally depending on the result of the game. And the game itself is implemented as a generalized state channel smart contract. So the entire execution process of the game is also entirely trust-free. And as you can see from the interaction, the interaction or interactiveness of the application is much, much better compared to if we directly implement this on the blockchain itself. And there's kind of another quick demo here. We actually are releasing something called Celer X platform, and it's basically built on top of this this application. But what it is a very targeted game-facing or game developer-facing platform, so that game developers who are very good at developing these kind of very small games can actually harness the power of blockchain and generate sustainable monetization flows. So if there's any game developers in the audience today, definitely talk to us. We're extremely excited to looking forward to this kind of independent game studios. As if you look at the 2018 and 2017, people have been focusing on technology advancement, but not so much on the real adoption and real usage of blockchain technology. But we think that this kind of a platform is building and leveraging the power of their tool, but also create real business opportunities for small game developers. So there is one kind of a business model in United States called scale-based real cash gaming. It's entirely legal in 38 different states. So basically, this kind of game that you can actually play for real money with your friend. And imagine if you're a game developer and you build some game on top of a Celer network. And this game is extremely popular, and a lot of people are playing and also exchanging money during the process. And during that process, you actually can run a Celer full node yourself and join a Celer network. So your users are basically routing their payments, their conditional payments through you. And during that process, you're directly generating revenue by just having real transactions on top of the Celer network. So we believe that this is an extremely viable use case, and we're going to release this this platform so that no more game developers who has no idea about how to use blockchain or how to interact with blockchain can take an existing HTML5 game and integrate with Celer under 20 minutes. So we have released a bunch of testnet. We released the first version of the testnet, which is this horse-like singing, last year, and we recently released this dog-like singing. This is actually our office dog, pretty recently. And there are a lot of features supported that we supported, like multi-node non-custodial payment, generalized payment network that can support this kind of a conditional payment functionality, and we have generalized state channel support and all that stuff. So I'm gonna skip this, because it's too long. Very simple question, why should developers care? Right, there are so many features. Well, because of this. One application, which is the Gono game you guys just saw, achieved 50 times user growth in just 3 months. And it started from 300 or 500 people playing this on a monthly basis, reaches very recently about 18,000 people that is actually actively playing on the game. And the power of blockchain is really shown here, because from our backend we are monitoring where are our users coming from, right? So our users are coming from actually 88 different countries, and interestingly we also have 5 users from Madagascar. So I'm seriously considering hosting a meetup there as well. So now this is some interesting statistics, and if you guys have any question, I can review more about our interesting statistics here as well. But currently, what we are seeing from this application is that it doesn't look like your garden variety of the decentralized application where there's no user retention, there's no active user generally do not engage with the application for too long. These numbers look like a real application, like a real mobile applications number. So we have a day summary retention of 20%, 12 minutes of data user engagement time, and over 1 month we process about 4 million off-chain transactions. So this is really happening, and we are running the largest scale generalized state channel network in the world right now. And from our users' feedback, what we learned is that okay, Celer X is actually better US, as if there's no blockchain. There are a lot of good words talking about that. However, I want to actually be very clear here that this is kind of all these feedbacks are coming from like kind of the developer community. But if we shift the focus to a broader user space, to like people who has no previous experience on top of blockchain, all these kind of a bubble, positive feedback start to collapse. Because layer 2 scaling platform is actually introducing additional layer of onboarding friction comparing to layer 1 blockchain. If you're just like, imagine that you just start to understand, oh, now I have this address, so I can hold this token and all that stuff. But now you're saying that you want me to deposit this token to some other kind of smart contract to join Celer Network. Does that mean that Celer Network actually holds our token? Does that mean Celer Network is a centralized solution? These kind of questions start to pop up very quickly from our users. And this is like what's bothering us right now, and we're trying to educate the user and educate the market to solve these kind of questions. Now, this is just a reminder that this is just one application on a paper money testnet. Like all the tokens flowing in this network is game token. We printed out that game token basically. However, we believe that this kind of smooth interaction enabled by the generalized state channel technology can actually create a high transaction volume and therefore provide the first or one of the first few sustainable monetization paths for developers building on top of the blockchain ecosystem. Because if you think about it today, if you look at Tron, if you look at US, if you look at all these ecosystems, or Ethereum not exactly, but many of the newly rising like ecosystem are basically subsidizing their developers. They're paying the developers to build some application. Because when the developer builds this application, there's no clear monetization path or very, very simple monetization path. But for this, because of the high transaction volume, hosting Celer Network node actually makes sense, and build application and hosting Celer node actually generate income. And we have released a bunch of SDKs, and there are a lot of applications being built on top of the Celer Network right now. These part I'm going to just skip. So we are mostly based in the United States. We recently just opened our Shanghai office. This is like this graph is 3 months old. We haven't got everyone's headshot yet. So we have about 30 people right now. These are some of the team's background, and we have about 34 million in bank. So we're very serious about this. To make the blockchain adoption real. Okay, so what's next? Let me just briefly talk about what's next for us. Well, what's next for us? First thing is that we're going to launch on mainnet very soon. And another thing is that, when we look at all these layer 2 scaling technologies, we look at, zero knowledge proof. You can use that as a kind of a scaling architecture. We look at the state channel. We look at all sorts of side chains, including Plasma, and then interactive computing. All of them are just the technology pieces. And our kind of a grand vision, or we think that a grand challenge to propose to the entire community is that these kind of individual technologies should not form their own single solution. They should somehow work together and provide a coherent solution, because they are actually creating different trade-off points in the trade-off plane, in a very complicated trade-off plane. Right? So, for example, state channel is really good for this kind of interactive applications. But if you have a large amount of participants in the application, this actually does not work. So you might actually consider using Plasma EVM, for example. So, but Plasma EVM, as we just chat about, offline, has long finite delays. So there's kind of a trade-off curve here that we want to explore that trade-off curve, so that whatever application scenario arises, we can actually find the suitable solution or suitable technology under this coherent solution. So that's where we are pushing the community forward. And of course, we are releasing our Celer X pretty soon. These are some of the channels that you guys can follow us. So that's kind of like a very, very quick introduction about the Celer's, where we are in terms of the technology. Let me check the time here. Okay.
You have some time.
I still have some time. Can I like switch the slides a little bit? Yeah. All right. So I'm gonna skip the part of the technology part because that's kind of demonstrated by the application or technology itself. But now what I'm going to talk a little bit about is the crypto economic construct. So there are several problems or challenges that need to be solved in layer 2 scaling. Because layer 2 scaling is making everything super fast, but it is also trading off something else. Especially for generalized state channel, the first trade-off is how to make off-chain state always available for on-chain field. What I mean by that is, tagging along with the great first talk that talks a lot about this stuff already. Even though I don't understand Korean, I'm using Google Translate to follow the talk actually. Let's say Alice and Bob is doing some state exchange. This is extremely simple one-hop payment channel. Right, so now you have the current state as the 49, number 49. And then Bob goes offline. As here can turn malicious and submit the older state proof to the on-chain bond contract. And then what happens after the challenge period, basically Alice is gonna get more dollar than she should have, right? So how do we solve this? On-chain centralized monitoring solution is definitely not a good choice because it created immediate incentive problem of collusion. And what about trust-free monitoring? There are some researchers proposing trust-free monitoring. How it works is basically like this. You have Bob submit the current state to a watchtower service, and the watchtower service is also putting down some money on chain. It's kind of like an honesty bond. If I do not do the job, you can take my money. What's going to happen is that if Alice is turned malicious, this watchtower service should be guarding the state for the user. And if not, user can later come back online and prove to that smart contract who is holding some kind of a honesty bond that this watchtower didn't do the job and then take the money. But this trust-free monitoring service also has significant disadvantages, including it doubles the overall liquidity lockup of this entire network. Because now you need to not only having this kind of channel operator lock up money, but also the monitoring services also need to lock up money. And it creates a very heterogeneous interface for safeguarding because sometimes it's very hard to even reason what is the value underlying a particular state. And it's created a very obscure and expensive pricing model for these kind of services, and it created extremely complex on-chain and off-chain interaction. For every kind of a state guarding request, you need to incur some certain kind of on-chain transaction cost. And in the end of the day, what it really provides is a very, very rigid insurance model. You basically get X% back for Y price, and that's it. As long as X% is not 100%, you'll always suffer from this collusion attack potential. So, how do we solve this? We propose something called the State Guardian Network, which is a special kind of sidechain with plasma-like semantics. So you stake your Celer token into this State Guardian Network sidechain and become a State Guardian. And when user goes offline, or when periodically the user wants to checkpoint the state, the user will just submit the state proof to this State Guardian Network, submit a hash of the state proof actually. And the state proof here can be really anything. It can be a game state, it can be a sign agreement, it can be an auction acknowledgement. It provides a very, very homogeneous interface for the user. Now, the immediate question to ask is that how many state guardians you will be guarding for your state, right? Well, that is determined by the payment. So let's say this user, Bob here, is paying like $1 per hour for this to this entire network to guard the state. And at the same time, there are other people paying the network as well. let's say this entire network is receiving $2 per hour as payment income flow. Now, Bob is constituting half of the income flow, and therefore, roughly about half of the state guardian will be guarding the state for Bob. So it's basically proportional to the income flow you generate to the network versus the overall overall like income flow generated received by the network. And of course, if you stake more Celer token, what's going to happen is that you basically get assigned with more work, statistically speaking, and therefore receive more payment. So Celer token here becomes like a work authorization token, so that if you stake your Celer, you do the work, you receive income. We also have a built-in collusion resistant system where the state guardians are randomly selected, and each of the state guardian will be assigned with a dispute slot. So if the malicious user comes online and do the kind of a dispute, and let's say guardian number 2 is also a bad guy here, and what's going to happen is that guardian number 3 can respond to this malicious settlement and also like submit the correct state proof. And at the same time, he will be able to prove that guardian number 2 didn't do his job and get guardian number 2's token to him. So it basically effectively kicked guardian number 2 out of the entire state guardian group. Now, a very valid question to ask is that, okay, what happens if number 2, number 3, and number 4, they're all malicious? What's going to happen then? Well, that becomes kind of the last resort, that when the user later comes back online, he can submit, because of the plasma semantic of this kind of a state guardian network, there is the capability to attribute history pretty accurately. So the Bob can actually have a proof of malicious behavior submitted to the state guardian network, and let the entire tokens staked on behalf of him be compensated to himself. So all these state guardians will be kicked out of the network. Now, that creates a very interesting economic dynamic here, because what is one Celer token? One Celer token represents an income flow if you do the work. So now, depending on what did Bob pay in the very beginning, the more Bob pays, the more number of Celer token will be guarding or responsible for Bob's state. And basically the potential loss will be recovered faster, because let's say Bob can stake his own Celer token into the system and start to earn income flow as well. So now it creates an insurance not against a certain hard and fixed number, it creates an insurance against a certain kind of income flow. And how each individual evaluate or value the income flow can be drastically different. And that opens a very flexible market dynamics here. And that is something about the state guardian network. And the second thing is connectivity chatting. In state channel network, you always have this case where you're about to win. Let's say you're about to win the chess, and you submit you pass the winning state proof to your opponent, and your opponent just goes away. Okay, so can we just let IS directly submit to complain on the blockchain, saying that, oh, my opponent just won away? Can we let the IS do that? Well, no, because blockchain cannot really differentiate between these three scenarios. The first is that Bob is really not responding, and the second is that Alice just kind of maliciously saying that, oh, Bob is not responding, but actually Bob is fully responding. And it can also be that it's not of their fault. It's just the network connection between them is not available right now. So we need a fallback data exchange fabric that is reasonably available, has attribution of availability time, and is extremely cost effective and does not require large amount of resources from the end users. We can use blockchain as a data availability service, basically meaning that if you're passing the data to your opponent and your opponent does not respond, you just pass that data also on the blockchain, assuming that everyone has reasonable accessibility to the blockchain itself. But it is definitely not it's definitely not cheap because like you're actually storing the state to the blockchain, and also it's definitely not like resource conserving because it actually requires all monitoring of the entire blockchain states to make sure that your opponent is not maliciously submitting a state to the blockchain. Now, how we solve that is to use, again, the state guardian network as a data availability service. It is reasonably available. It has attribution of availability time. That's no problem. The on-chain state storage is also very cheap because you're only storing the storage in a temporary time. So because of the state guardian's nature, every state stored in the state guardian network has timeout associated with it. So in the end of the day, the state stored in the state guardian network will only become a hash versus a timeout value. And it actually requires only all log-in monitoring. This is like an inspiration we draw from the Plasma Cache. So basically, every state is kind of having a pre-assigned address. If you're interacting with your counterparty, you only need to monitor like this much of data is going to be fine. And basically, if Alice submits a state proof, she will wait for timeout, and if the timeout passes, she will start a one-bit claim challenge with the monetization bond. And Bob, if responded to that challenge with also a monetization bond, what's going to happen is that Alice can actually have the state availability attestation from the state guardian network, and then Bob will lose the challenge. And if Alice here is malicious, what's going to happen is that Alice will submit a state proof, and Bob will actually respond to the state proof before the timeout actually expires. So that is kind of a very, very quick summary about the state guardian network. And another kind of a challenge in the state channel network is the network liquidity. So in state channel network, what we envision in the future, the state channel network is going to look like this. This is going to be a multi-hub network, basically. You have a hub that is connected to a lot of end users, and then the hubs are connected together. Now, if we zoom in and look at each of the hubs, because each of the hubs, when trying to relay some payment in a trust-free way, also need to have some corresponding channel deposit to each of the state channels. So what's going to happen is that the OSP, the off-chain service provider here, is going to run out of money very, very fast. So the problem in our current crypto space is that people have money, may not have the engineer capability or interest to run the stuff. And people who have engineer capability to run and operate an off-chain service provider may not have the required capital to serve these kind of large amount of users. So what's going to result? The result is going to be slow adoption and also very quickly centralization of this entire network. Only like whales can run this stuff. So we introduced two solutions to act as a combined solution for the network liquidity challenge. The first is called proof of liquidity commitment mining, the first part. So the proof of liquidity commitment mining is to incentivize the entire network to create a very abundant and stable liquidity pool for such a network. So it works basically like a virtual mining process where you have two liquidity backers here. One is waiting to lock up 10 ETH for 3 years for nothing to back Stellar network, and the other is 30 ETH for 2 years. Now, their virtual mining power becomes so basically a multiplier between these two things. And newly generated Stellar token will be awarded proportionally to their virtual mining power. So with this incentive, and also because of the Stellar network's income flow earning power, so they become a very positive incentive to, especially in the beginning, create a very stable and abundant liquidity pool for the entire network to operate. Now we have the pool of liquidity, we have the pool of money sitting here. How do we use them? Right? So we created something called a liquidity backing option. Let's say this guy is some like technology savvy guy that wants to run an off-chain service but does not have the liquidity required to do that. Now what it can do is that it can start an auction contract on the blockchain directly saying that I need 100 ETH for 30 days with maximum supportable interest rate of 1%. And then all these liquidity backers will be eligible to bid on this contract saying that, okay, I'm willing to lend you for 0.5% interest rate. Some other guy is going to say, oh, I'm willing to lend you for 1% interest rate. And some other guys are also going to say, oh, 0.5% increase rate. But the difference between these two bits are this first bit actually is also at the same time saying that I'm willing to stake 20 Stellar token as kind of my priority node. So Stellar token now here become also Stellar token here also serves as an additional functionality of priority determination between different bits. So that becomes like basically if you have more Stellar token, statistically speaking, you will have more chances to be used as a backing asset and therefore earning more interest rate. So then we take the second score option. That's kind of some detail. So now this is like the C economic construct that we propose. And if you really think about this, it completes the circle of off-chain economic design, right? Because the liquidity backing auction and the proof of liquidity commitment mining process is to ensure that we can easily bring on-chain state to the off-chain world, because we solve this kind of a liquidity shortage problem. And then the state guardian network is here to ensure that whenever needed, we can actually bring the off-chain state back to on-chain. So it's kind of complete the entire circle of the crypto economics incentive design. So yeah, that's kind of like a quick introduction about our economic construct as well. Yeah. All right. So any questions? Yeah. So one interesting thing is like we have a lot of Korean users. I'm not sure like if there's any one sitting in the crowd that actually use the Stellar X application, but Korean users actually rank the number 4 in our like global user count rank. And the first one is United States. Second is China. Guess who is third? Japan. Yeah. Any more guesses? Sorry? Brazil? Yeah. Brazil, we have some users, but like not on the top 10 though. We want to try to get some more Brazil users. It's actually United Kingdom, which surprised me as well. So, okay. Yeah.
One question for me is that in order to develop Stellar-based applications,
right.
What